Hello everyone and welcome to my YouTube channel. Today we are going to see class 10 science 1 chapter number 2 periodic classification of elements, and this is a part 2. In a part 1 already we studied about the periodic classification done by the different scientists. In that, first we studied about the Doberinus triad, second we studied about the Newland's octave, and then the Mendeleev's periodic classification. And lastly, we studied about the Mendeleev's periodic table, and in that the demerits we had already studied, which means that periodic classification done by the Mendeleev was also a one failure in this particular classification. And this all the previous classification of elements whatever we have studied till date is failures with the new elements discovered with time. Means as the different elements discovered, these the previous classifications or the previous scientists were unable to place them in their classification. And that's why that particular or all the three, the previous what we have studied was rejected with respect to the time. After that, the another scientist who had given this particular classification, the next what we are going to study, in that he changed the basic concept of previous all the classification, because previous all the classification whatever we studied all the three, in that atomic mass was considered as the basic part for the classification. All the three classification were based on the atomic masses of an element. Whereas this particular scientist who gave the modern periodic classification, in that he changed this concept completely, because when he started to classify the element, that time the atomic numbers were known to the scientist, because the previous classification, that time the electrons or the internal part of the atom were not known, or science was not developed that much in that era. So after the discovery of the electron, scientists started exploring the relation between the electron number and the atomic number. They gave the concept of the atomic number that time, and then Mendeleev's periodic table only indicated the serial number in that classification. If you will see the periodic table, the modern periodic table, in that numbers what he has given, the atomic number, that was used only for the serial numbers to arrange them. After that, what they are saying in this particular part is Henry Moseley, the scientist who given this particular classification, with the help of the experiment done using X-ray tube, he performed the experiment to find out the atomic number of an elements and the positive charges present in the nucleus, all that he studied, and then he revealed that the atomic number is more fundamental property of an element than its atomic mass. And then according to that, he gave the statement for the modern periodic law: properties of elements are periodic function of their atomic numbers. He gave the law for the modern periodic law. This is also known as the modern periodic law. Properties of elements are a periodic function of their atomic numbers. After that, the modern periodic table long form, also we are calling it the long form of a periodic table. In that, the structure we are going to see, the complete structure of that, what exactly this particular table is. And in this particular structure of the modern periodic table, we will just see it with the table itself over here. If you will see in this, we have in all 18 groups, starting from 1 2 3 4 till the 18 we are having. And these vertical columns what we are having, this 18 columns, this 18 columns are called as the groups. They are called as the groups. Group number 1, 2, 3, 4, 5, 6 till the 18 groups. And this horizontal what we are having, 1, then 2, 3, 4, like this we are having total 7. This 7 what we are having, they are called as the periods. Period 1, period 1, period 2, period 3, 4, 5, 6 and 7. These are the 7 periods. So modern periodic table or the long form of a periodic table, it's having a 18 groups and 7 periods. The columns what we are having, the groups what we are having, they are also called as a column. Column number 1, 2, 3, 4. The first column, group number 1. Second column, group number 2. Like that we are having. And then the rows what we are having, the horizontal ones what I had drawn over here now, they are called as the period. The first row element, second row element, third row element, or the third period element, third row, third period. Both are same. Now, in this particular classification, if you will see the further, this particular table is given as a S block. The first two groups is the S block. This central part, if you will see, it's a D block, and this one is a P block. This is about the upper portion of the, this is S, this is D, this is P. There is one more block at the bottom of this. If you will see this at the bottom of the table, they have kept this F block. Actually this F block, what we are having, they are called as the lanthanide and actinide. This star one, if you will see, that is a lanthanide, and this hash one, if you will see, this one is a actinide. You can see La, that is a lanthanum, and the Ac, that is the actinum. Now this two what we are having, actually they are not at the bottom of this periodic table, they are present over here. This is the lanthanide and this is the actinide. So this lanthanide is present over here and the actinide is present over here. Now that's why they are placed over here. This complete series, the lanthanide series, is present over here at the same spot. So in a textbook, in a 2-dimension, it is not possible to show them. So that's why they have drawn it at the bottom. Same way about the actinide series also, it's present over here, one above the other, all the elements. That's why we are calling also about the modern periodic table. It's a 3-dimensional structure or the classification. Further is, when we talk about this particular modern periodic table, the complete structure, before that I just want to take one of this. You can see over here in this number indicates the atomic number. This indicates what a atomic number means, Z. After that, if you will see this is the symbol. Then afterward we are having a name and then the atomic mass. Here also they have given, if I want to just to make it clear, this one as the atomic number, this one as a symbol, this one as a name, and this one as a atomic mass. So complete modern periodic table, if you will see in this, each and every element is having atomic number, symbol, name, and atomic mass. And this entire table what we are having, it gives an idea about so many things. It's giving an idea about so many things. First of all, atomic number, that already we have seen, then the symbol of the element, name of the element, atomic mass of the element. After that, it's not only this particular table gives an idea about the valency of the element also. That also we will see. At the later stage, we have to study about that also. Before that, we have a certain names for the different groups and the different periods. When we talk about, if you have a notebook and a pen with you, you can note it down. The first one, period number one, what we are having. Period number one is known as the shortest period. Why it is known as the shortest period? Because here if you will see only two elements are there. One is a hydrogen and one is a helium. Then the second and third, these two periods are known as the short periods. Why they are known as a short period? Because if you will see here, this portion is a blank and we have only the 8 elements in this. Even in a period number 3 also only 8 elements are there. That's why they are known as the short periods. When we talk about the period number 4 and 5, this 4 and 5 what we are having, they are known as the long periods. They are known as the long periods because both are having a 18 elements. So period number 4 and 5 are the long period of the modern periodic table. Then afterward, when we will see about the period number 6, it's called as the longest, because in this we have overall 32 elements present in this. This elements, along with that the lengthenide is also there, and that's why it is known as the longest period of the modern periodic table. And the last one is known as a incomplete. Last one, seventh period, is known as the incomplete because here these elements, the last elements what we are having, they are still under the research. Now this is about the period. Now let's talk about the groups. The first group what we are having, the group number 1, is known as a group of alkali metals. Group number 2 is known as a alkaline earth metals. Group number 17 is known as a group of halogens. And here also we are having a separate column. Group number 18 is a group of noble gases, which is also known as the zero group. Group 0, zero group, or the group of noble gases, or group number 18, this all are the same. Group number 17, group number of, or the group of halogens. Group number 2, alkaline earth metals. Group number 1 is a group of alkali metals. Now if you will see in a back part of the this particular long form structure of the modern periodic table that already we have discussed, then the modern periodic table and electronic configuration of element, that part we will see now. When we talk about the electronic configuration, the elements which are placed in the same group, like here in the table, if I want to discuss about hydrogen, lithium, sodium, potassium, rubidium, cesium and the francium, these all the elements will show the similarity in their electronic configuration. What is that similarity? Their group number is 1. Their group number is a 1. So these elements, all elements what we are having, starting from hydrogen till the francium, all will have 1 electron in their outermost orbit. They will have only 1 electron in their outermost orbit. Now when we talk about the outermost orbit, we are talking about the 1. But what about the number of orbits they are having? The number of orbits for these elements will be same as the number of period in which they are present. Means hydrogen will have only 1 orbit because it's present in a period number 1. Lithium will have 2 orbit, sodium will have 3 orbit, potassium 4, rubidium 5, cesium 6 and francium 7. Means the period will decide how many period how many orbits are there in that particular atom or atom of that particular element, and the group will decide total how many electron will be there in the outermost orbit of the atom of the element. So here when we talk about, if I am taking some other example like beryllium, if I am taking over here, beryllium is present in a group number 2, means the outermost orbit will have a 2 electron, and total how many orbits will be there? 2 orbit. Why? Because it's present in a period number 2. Suppose if I am taking the strontium, which is present over here, again what will happen? It will have total how many orbits? It will have a 5 orbit, and the last orbit will have only 2 electron because it's present in a group number 2 and period number 5. So this is the numbers, the period number and the group number decides the number of orbits present in an atom and the number of electron in the outermost orbit. And this, when we talk about the outermost orbit, if the number of electron is known in that, then we can talk about their valencies. So valency, when we talk about in this particular modern periodic table, valency goes on increasing from here to here and decreasing from here to here. Means what? If I want to draw it about the valency is behaving in this way. First it's increasing and then it's decreasing. This is the manner of valency, because valency depends on the number of electron in the outermost orbit. So here the valency, when we talk about here 1, 2, 3, 4, and then again it will go on reducing, and here 0, 1, 2, 3. But the negative valency means they will accept. This will accept and this will donate the electrons. Further part, when you will see in this, they have given about the group and electronic configuration, that already we have discussed. Now about period and electronic configuration. When we talk about the period and electronic configuration, that already we have discussed about the modern periodic table. In this, if you will see, the one part is this zigzag line. This zigzag line is nothing but shows the metalloids, because this side we have metals and this side we have non-metals, and this is junction of a metalloids. This also we will study when we will go towards the metals and non-metallic characters in the modern periodic table. Periodic and electronic configuration, already we have discussed about this. You can go through this part. They have taken the example of the potassium and argon and they explained about this. And electronic capacity of the electronic shell, which already you have said in a lower standard formula, is a 2n square, and the electronic capacity they have mentioned. In the next part we will talk about the periodic trends in the modern periodic table.